chat. Who's okay? So shall we start? All of you are okay. So okay, I am also recording this, so we can. I'll move it up. Okay, what I thought, I'll give you one small revision. Okay, before we get into core of the topic today, that is STP, Spanning Tree Protocol. Okay, now I hope you can see the picture. We have a network with the 192.168.10 as the network ID because I have put a subnet mask /24. That means first 24 bits are network ID and the last 8 bits are host ID. So this entire network, what we see with a switch here and 3 hosts, they belong to one network, one LAN. Okay. Now, what is the purpose of switch? We connect the different hosts and we give different IP addresses to them, and we also define the subnet mask for that. So typically what happens in packet tracer is when you type in this value, it automatically finds out that this is the subnet mask is this, because that's how the number we are starting with depends on that. Anyway, we'll not go into the details of that. Later on we'll talk about it. So now what happens in this LAN is we can communicate among the hosts within the LAN with the IP addresses that we have. Now, if you want to actually communicate with outside of this network, we need the help of router, and we also should know what is the IP address of the interface that router has on this LAN. So there is one leg on this side and another leg on the other network. So the router here will be watching all the communication that is happening on this side, and then if it is to be taken in, it will take it in and pass it on to other side. Now, is what is actually initiating that interaction among this host? Any command that you give. Now suppose you give a ping command from this host and you want to ping this guy h2, so you will say ping 192.168.10.2. now it is, what does the host do? It actually looks at its own IP address, which happens to be 0.2. So sorry, this is I have given the same IP address here. That's wrong. So I should give something different. So let me correct it. So this is 2 and this is 3. Okay. Now when you say ping 10.3, it first of all finds out where this host is currently on. It is currently on this network 192.168.10, and its own IP address is 2, and you are giving a IP address of another host which is in the same network. So that means it knows that I can reach this particular host within this LAN. I don't need to take the help of router. That much it understands. Okay, that let us stop there, and then I will come to that one more detail now slowly. Now suppose if I say from the same host ping 10 dot, okay, let me 10.0.0.2. Now again this host checks whether what IP address you want to reach out to. I want to reach out to some IP address which is not within this LAN, which is outside of this LAN. Now it doesn't know where it is. It has only one thing configured, provided it is configured, the default gateway. Okay, you need to make sure that the default gateway is configured on all the hosts. If you want to connect to some other host which is not within the same LAN, if you do not configure the default gateway with some IP address of this router, which is the only way out for you to come out of this your own LAN and go to some other LAN. If you don't do this configuration, it cannot do anything. So you will say that no, request failure, because it cannot reach out to some other hosts which are in the outside of this network. That is the reason you see that when the packet tracer you don't set up the default gateway, you get always request timeout, because ping command is not even sent out of the network. Now what did you what you have to do here, default gateway on all the hosts, all these hosts, you need to configure it with the IP address of the router, which is the only way out for you to go out of this network. So you configure this particular IP address in all the hosts as a default gateway so that the packet can be sent to the router. Now, what does the host do? If at all it finds that I want to talk to some other host with the IP address which is same as this LAN, I can find out within the LAN and it sends out on the same LAN. Now, if it finds that I am interested in looking for some host which is outside of this LAN, which it can find out from its own IP address and its own subnet mask that it is outside of LAN, and it knows that my only solace is the router, which knows the path to reach it. Okay, if it is not connected immediately, it will even send it to some other router and then somehow it will reach. So that's how it happens. Now, one more thing here I want you to remember, when we are talking on this particular LAN, we are not going to send the IP packet as it is. So let me take this place. I have a ping command which is ICMP packet, which is going into IP packet, which is L3 IP packet. Now, as such, you cannot send it the IP packet on the LAN. You need to pack it on another L2 packet, which is Ethernet. Now, we are having Ethernet LAN. So, this IP has to be packed inside this IP, and IP header is here, and ping packet has to be packed here. Okay, ICMP packet is packed here. So, you know that as a layered architecture, if you want to communicate with anybody, you have to come to L2 level, and of course L1 is also there based on whether you are having a Wi-Fi or fiber optics or Ethernet port, you will be sending it across. Now there is another problem. On Ethernet LAN, the addresses that you are having are MAC addresses. MAC addresses. You don't communicate with the IP addresses on the L2 level. Now you are interested in this host talking to this 10.02, which is not in this same LAN. So host has identified that it has to send it to 1.168.10.1, which is set configured as the default gateway. But it has only the IP address, but it doesn't know the MAC address of our router. This particular interface has a MAC address. So we need to use the destination MAC address in the Ethernet packet for it to send it to the router. Please remember, we cannot use the IP address as such to be communicating on the L2. So that is where our OR protocol, which is coming in here, we need to address resolution you have to do. Means you want to resolve the address of this particular gateway IP address to its own MAC address, which will be filled with a default MAC address, and then it will be put on the LAN. So we will come to that out maybe in the lab 6 for other sections, and even section C would have already learnt about ORP, but section B I have already covered this ORP, but I am just assuming that even if you don't remember any of this, you can just catch up on this revision that I am doing. So let me summarize it. Now, once the host identifies that it has to send the packet to the router interface, which is also in the same LAN, the reason was that the final destination is somewhere here, which is outside of the LAN. So router will take care of sending the packet across. Now, even to reach the router, we need to have the MAC address of the router. Now, that will not be known to all the hosts. It only knows the default gateway IP address. It doesn't know the MAC address. So our protocol comes in and then it learns about the MAC address. So assume that now all the hosts also know the default gateway's MAC address. So because the router is going to respond back with its own MAC address, and then it will put it in the default MAC address, and then source MAC address of course will be the host source MAC address, and then send the packet across. So this is how any packet escapes from the LAN to outside the network. Now what happens in the router? Okay, let me explain here. When it comes here again, this router has to send it to this particular host. Now here also the router knows that okay, I am on this interface and the packet which is coming from the other end has to reach some host within this particular host where I am part of. It is part of two network. Otherwise, router's job is not done. It has to be part of one, two, or three or more networks. But still, this router also doesn't know what is the MAC address of this particular IP, which is coming from this. Remember one thing, the IP packets addresses whatever has been put, the source MAC address and destination MAC addresses, they are not changed when they reach the router. So router still knows when it opens up the IP packet, okay, it opens up the IP packet here and then looks at the content of destination IP address, which happens to be this. So what does it do? It sends a ARP request, again address resolution, and gets the MAC address of this particular host and then puts a Ethernet packet and sends it. So remember one thing, when the packet comes here, ping packet remains same and the L3 IP packet remains the same, but L2 changes because it is on different network and the MAC address has to be changed. So it will put the destination MAC address of this guy and then sends it across. Because it is within the LAN, it reaches there. So this is how any packet going across the routers on different networks, every time the router has to open up the packet, IP packet, and then looks at the IP address, whether it is on the same IP address or it has to go to some other router, it will decide. Then it will extract the MAC address from the destination and creates a new Ethernet frame and sends it on the LAN. So whatever Ethernet frame you have here will be changed here when it is going on this network. So I hope this is easy to understand, or maybe I am something adding a new thing. Okay, now some jokes are there, but nothing serious. Any questions on whatever I explained? Anybody having any question? I will pause. I don't want to go very fast. I want to use this opportunity to bring all of you on the same page. One more chat. Okay, no from nothing from anybody else has any questions? Or all of you are hungry? Okay, fine. This is just a overview. Now let us zoom into one particular LAN. Okay, I am zooming into one particular LAN. Remember, we were discussing about two LANs and then how they are talking to each other. Now within the LAN, what happens is we can actually have many hosts connected together using many different devices. One is a hub, other one is a bridge, then third one is a switch. So let me number them: 1, 2, 3. I can use any of these three devices to add my host to this one particular LAN. Remember, they are all helping you to connect different hosts to a LAN. Now, why do we need different devices? First of all, we need more devices because each of the devices will have a limit on number of ports. Number of ports that you have may be limited on a hub or a switch. And bridge, so far we have been thinking that it has only two ports, but it may also be called more having more ports, and we may even call it as a bridge. But all of them are helping us to connect more hosts to the same LAN. That means what? The network ID of the host they belong to, they remain the same. Now this, you know that it has got 254 hosts can be connected on this network, because 255 is broadcast address, 0 is not a valid host ID. So the rest of these are all two host IDs which are not used. So you have remaining 254 hosts can be connected, but you may have hubs with only 10 ports, switches with maybe 48 ports. You can maximum connect with one single hub or a switch only some 50-60 hosts, but you can actually go up to 254. Then what you need, you connect more number of hosts and switches and expand the LAN that you have. So we will call each of this entire LAN that you get is a physical LAN, and what you realize using one particular hub or a bridge or a switch, we call it as a logical LAN. We are expanding it, extending the LAN. Remember, all of them are operating at L2 level. Okay, remember L2 level. L3 is not there because we are in the same LAN. All the hosts in this LAN are having the same network ID and the host IDs are different. Now, if you are communicating among the hosts within the same LAN, we don't need the help of router. Router comes in only when we need to go from one network to another network, wherein the network IDs are different. Here, these bridges and hubs will do the job for us if you want to communicate with them. But still, remember one thing. Here also, the IP addresses happens to have the same network ID, understood. Host IDs are different, but still, you cannot communicate on the LAN using these IP addresses. The same thing what I explained earlier holds good here also. So they need to get the MAC addresses of all the devices. Okay, MAC addresses of all the devices has to be maintained in a cache, or cache it is called, in each of the hosts if they want to communicate with them. They will only have the MAC addresses of the host they are interested in communicating. Okay, it's like this: when in your mobile phone you can store many mobile numbers, but you will only store the mobile numbers with whom you are interested in communicating with. So each of the hosts, though it knows that 254 hosts are there in the LAN, but they may not be interested in communicating with all of them. So they store only the MAC addresses of the interested parties, interested hosts within the LAN, and then whenever they want it, they will look at the IP address, and then they know that for this IP address, this host has a MAC address of so and so. So it will pick that MAC address and form a Ethernet frame and send it on the LAN. So remember, this is what happens when you are communicating among the hosts within the LAN. Now, I hope you remember, or you are also already aware, that hubs normally, when they see a frame coming from any host, they'll send it on all other hosts they are connected to. It will not send it back to the same guy, but it will send it to all other ports. I will say all other ports because I am not saying all other hosts, because a hub may be connected to another hub, or a hub can be connected to a bridge, or it could be connected to a switch. So hub takes it from one port. It could be directly from the host, or it could be from another hub, or another switch, or another bridge. See, remember, these bridges and hubs and switches are like a soldering between two line wires. You are connecting wires. So they are like a, whether you are connecting two wires, or maybe switch is like a n number of wires are soldered together. It's something similar to that. Whatever comes in goes out on all other ports. So it's not always true. Let me come to that. So hub will do the job of sending it to all of them, whereas bridge and switch, they are little intelligent. What they do is they learn which are the MAC addresses are on which side of the network, or which port they are available. Okay, so they will try to identify, instead of broadcasting or flooding the frames, Ethernet frames on all the ports, hub and bridge, sorry, bridge and switch, they only send it on interested ports, or the ports which are supposed to be connected to or to be sent. So let me summarize. Now let me come down. A hub, a hub will send it on all ports after receiving it. This is hub. A bridge, if I call it as two port is a bridge, then it will receive on one and it will send it to other side only if that MAC address is on this side. Okay, if it knows that the MAC address is on this side, if it doesn't know where it is, it will flood it. Otherwise, once it learns it, it will send it only on need basis. That means what? All these hub and bridges and switches listen to the ports which are they are connected to, and then they look at the MAC address, they receive it, they look at the MAC address, and then send it to only the ports where the particular MAC address is available. If they learn, if they know that, it's like somebody standing in a fire road junction. If the person is knowledgeable, any vehicle coming on the way, if they ask for the route, where, how do I reach Mysore, or how do I reach Chennai, then it will direct that to particular direction. If suppose if the person doesn't know, he may show both the direction. You cannot go in both, but you may go in one direction. But still, in packet, what you can do is, what happens when a packet needs to be sent on multiple ports, it is copied on multiple times, it is copied, and it is sent, the same copy is sent on all of them. So remember, hub or a bridge or a switch do not change anything to the content of the frames it receives. Okay, it doesn't change the frames it receives, it just copies the frames and sends it on all of them. Whether it sends it on all of them or not depends on whether they know where the destination MAC address is. whether the host or a host, most likely a host or maybe a router interface, we don't know. If it is available on a particular port, it will send it on that. If it knows that it is only on that particular port available, it will send it on only that port. It will not send it on all of them. So till it learns, it will send it on all of them. Later on, it converges. So this is the summary of what I wanted to cover. Okay, I think what's the time we have crossed? Okay, 15 minutes. Now there is a chat. Okay, there is no fixed slide. I am talking general how to understand this whole thing. Okay, there is nothing specific to any slide. Whatever we have been learned so far, I have covered. Any questions from anybody? Maybe I will open the window. You don't have to raise the voice hand. Either you can chat or you can come online and tell me. ARP table maintained. Sir, is the ARP table maintained? Yes, ARP table is maintained by whom? By every host. Okay. Uh, uh, it is also maintained at every ARP table is maintained at the host level, as well as the bridges and switches. Okay, which are intelligent enough devices. They also maintain the ARP table because they need to know which MAC address is on which port, so they will also be maintaining forwarding table. We will not call it as ARP table, but we will call it as forwarding table. The mapping to a MAC address is forwarding table here. ARP table is on the host level. Okay, so when you are interested host you are talking to, then you can maintain the ARP cache, and then you don't need to do the ARP request and reply, wait for that, and you can directly communicate. It's outside the context. I have already mentioned it. Please don't disturb the class by asking questions which are already been answered in my announcement. Please ask which are relevant to the lecture which is going on. Okay, it's a diversion for everybody. Please don't disturb the class with questions out of the topic. Okay, now let us now get into the crux of the discussion today. Okay, having learned that bridges are learning something, now that's what we are trying to understand now with forwarding by bridges. Okay, so okay, now symbol of a bridge, purpose of a bridge is to extend a physical or a LAN to a larger extent. Okay, some small physical LANs are there, you are making it into a bigger one. Okay, bridges pass on the frames between two different LAN segments. Now let me give an example here. This bridge is between two different physical LANs, and we are expanding into a logical LAN which is larger enough. I don't know whether I mentioned it in a reverse direction, reverse way. So this is entire LAN, and small physical segments are there. We are extending the small physical LANs into bigger ones. Okay, now here let me clear this thing. Forward all the frames they receive on a port to other port? Okay, as I told you, bridges and switches are intelligent till they learn, or they are dumb till they learn. They become intelligent when they learn. Okay, it's like any human being, will become intelligent when we learn something. So bridges also initially they are dumb, they don't know where the MAC addresses are. Please do remember, when they power up, when they come up, bridges come up, and laptops or desktops are connected and they are also coming up, nobody knows which host is connected to which LAN. Okay, so on power on, bridges are dumb, they don't know. Based on the communication happening between different hosts, while they talk, they look at the frames and then they learn. How do they learn? Each frame that comes in will have a source MAC address and destination MAC address, right? MAC addresses are there in each frame that it receives. And remember, they always listen. They always listen on all the segment they are part of. So they see all the packets which are going across different segments. So they also look at the source address and destination MAC address. Based on the source address, they know if it is receiving on this particular segment with a source address or some MAC address, it knows that this particular source MAC is on this segment. So they learn. So this is not an ARP table. Please remember, ARP table is this is only a MAC address to port mapping. Okay, which MAC address is on which port? Okay, which port? So every bridge has a port number, and it will map it to this MAC is available on this port number. Similarly, some other port is there, it will know that this MAC address, is on some other port. So that mapping is learned by looking at the frames which are being transacted over the network. So as the if all the hosts are coming up and then they are all quiet, they don't use the network at all, then the bridges are also unaware of what is happening, right? They don't even know that how many hosts are there, whether what are their MAC addresses, they don't know. But once they start talking, then you come to know about the bridges, come to know about which are the MACs available on which part of the segment, and they start sending it across only when it is required to be sent. Okay, so that's what is called forwarding table. Now, how many entries that you need? Finally, suppose all the hosts are now talking, then each with each other, then there will be 5 entries. Okay, because for each of the unique MAC addresses of these 5 hosts, okay, remember all the MAC addresses are unique. Okay, and then different port numbers, it could be same port number or different port number based on where they fall into. Okay, so one example, now suppose bridge 1 is here. Okay, bridge 1 is here. Now A and B are here on this side of the port, so it has to say that A and B are on port number 1. Okay, and then it knows that C, D are reachable through 2. Please remember, let me remove this writing. Um, when they say that C and D are on 2, doesn't mean that it is on this directly connected. It could be somewhere else also, but it knows that if I send it here, the frame finally may reach here, right? So for as far as the B1 is concerned, it knows that okay, I see this guy on this side of my um, port, on this port, so it will fill up with the values too. Okay, so this is how they fill up the forwarding table on each of the bridges. So they can finally, when they get the frames, okay, they can communicate. So I hope this is clear to you, and this is needs to be updated periodically. Please remember, this forwarding table is not frozen forever, because if suppose it's a laptop and this LAN is a Wi-Fi segment, okay, it's not wireless segment. So you are inside a new block, and then you go to the admin block. Now you are connecting the same, your host, your MAC address is not changing, but you are connecting to the same network, our RU network. You are in the same LAN, but you are in a different segment. Suppose you are in a new block here, this segment is admin block. Then you are connecting now through this particular Wi-Fi router. Then the bridges have to learn whatever is in between. Either it could be a bridge or a switch or anybody. Now they have to invalidate the previous entry because you were here and then you moved here. So it has to now learn that this MAC address is no longer in this thing. So it will invalidate particular entry and then make this entry as 1 or whatever, 2 to 1 or 1 to 2, whatever. So this is how the network is adaptable to movement of host, okay, or adding new host or adding new switches and LANs and new set of hosts. Maybe suddenly we can say that in SOCE more students have come, new set of students and new classrooms are enabled, then you have a whole set of host and network is added, okay, or a segment is added. So this is how it is adaptable. So where will the forwarding table be stored? In that header packet? No, forwarding table is not going across the network. Please remember, let me explain it again. It's a valid question. Forwarding table is within the bridges. Okay, it is to make the make our router intelligent enough to selectively send the frames. So there are, remember one thing, bridges are not changing the packets or frames that are they are receiving. So they are only trying to find out how do I manage the frames, how do I send it across, do I have to send it on all of them or should I send it to only specific ports. So they are learning. So this bridge forwarding table is in the bridge, inside the bridge, and the mapping between the port number is local to a bridge. Please remember, this one refers to the bridge number 1, whereas this one is actually bridge number 2, this port. So this itself is a clear indication that these forwarding tables are local to the bridges. and MAC addresses are global here. In our case, A and B, you can get a packet from anybody saying that I am interested in talking to A. So they may put the destination MAC address of A. So these MAC addresses are across the entire LAN because hosts are distributed all over the place, whereas the port numbers are local to the bridges. So effectively, the forwarding table is nothing but mapping a MAC address to which port I need to send it to. Okay. So remember, we initially started off in an interaction at the application level, like ICMP, ping packet. Ping is a application command that we start with. We are initiating a traffic using some command, ping command. Now, ping command is initiating some more traffic, auth packet, because it has to learn the MAC addresses of the target host it wants to reach. Now imagine that the ping is happening within the LAN. Now it knows that the other IP address I am interested in pinging is also in the same LAN. So it will create a auth packet within the LAN. Now it gets the MAC address reply from the host, target host or a destination host. Then it creates a frame. Now the frame has to travel now. See, the original host, you did a ping to this guy. Now it initially sent a ARP request which came and then come here. Now you may wonder how does the ARP packet itself will go. Okay, now I have to clarify one important thing here. When you send a ARP packet, the bridges know that it doesn't know the MAC address of, or it is doesn't even know MAC address at all. It is sending the IP address, destination IP address. I am interested in getting the MAC address of IP address of D. So ARP doesn't have a MAC address. ARP packet itself doesn't have a MAC address. It is sending a broadcast packet on the Ethernet frame. So what do these bridges do when they see a broadcast packet? It doesn't look into the forwarding table because broadcast means broadcast. I need to send it on all of them. Even switches do broadcast means it will send it on all ports. Bridges also will send it on whichever port it receives, it will send it on the other port. So initially ARP is sent as a broadcast to everybody. Only the host whose IP address is mentioned in the ARP will respond back with its own MAC address. Now it will put its own MAC address and it also knows the sender's MAC address because you don't know the target MAC address, but you know your own MAC address. So source MAC address is filled, destination MAC address is a broadcast address, and the packet frame goes, and all the intermediate bridges sends it to everybody, and the interested host whose IP address matches with the IP address it is sent in the ARP packet, that fellow responds with the source MAC address and destination MAC address specifically to the particular row. Now, again, the bridges may not know that A is here, so it may put it on all the frames, all the segments. But what happens is the normal tendency is if the frame is not addressed to you, if it is not addressed to your MAC address, you ignore it. If it is addressed to if the destination MAC address is having a broadcast address, you pass it up. Okay, broadcast IP frames are passed up. If it is specific to a particular MAC address and it's not my MAC address, I ignore it. The host will do the same thing. Okay, all the hosts listening will ignore the frame. Finally, that will land here, and this guy learns about the MAC address. Then it sends specific to that MAC, and they communicate. So this is how the communication happens in the beginning. Everything is initiated because of one guy sitting on the desktop writing a ping command. Okay, so sir got disconnected. Can you please let him in? Oh, sorry. I am not getting the request. Uh, admit all. Sorry. Okay. Thank you for let me telling me. Okay. Don't worry. Even if you have missed something, this recording I am doing, so you will not miss. Hopefully, I think recording is happening. Okay. Now, simple. I don't think I need to go through this quiz, which you can always read it up. What I am trying to tell is does the bridge receive the frames addressed to A or B or C on the port number 1? Yes. And then what does the bridge do when it receives the frames addressed to the host present on the same segment? Now, suppose if it knows already it is on the same segment, bridge doesn't have to do anything. It will not forward it. Okay. It will not, it will read it. Please remember, it will read it and then ignore it. Okay. That's all. So that's about this. Now is that we are ready now to learn about what is transparent bridge algorithm. Okay. Now, how does it learn? Okay. Forwarding table in the bridge is initially empty. Okay. Now I am going through step by step. I don't know whether all the sections have gone through these slides or not, so let me go one by one. Initially the forwarding table which is inside the bridges are empty because everything is coming up. We don't even know which host is connected to which side of the LAN, and whether they are interested in communicating or they are just be there and not using the network at all. Okay, we don't know. So when they initiate communication, then where there is a traffic going on the LAN, bridges receive it, and if they don't know where the target destination MAC address is, or if it is a broadcast address, it will send it across to all the ports. Okay, all the ports it is connected to. So in fact, it doesn't even know how many nodes are there. Okay, so bridges themselves are normally configured in promiscuous mode. What is promiscuous? It is silently listening. Okay, it is not, remember, bridges are not actually initiating any traffic into the LAN. They are just there. They receive it from one end, put it on the other end, or they receive it and keep quiet. They just observe what is happening on the LAN. Okay, so if the communication is between the, if it knows that it is communication is between the host on this side, it will just keep quiet. It doesn't have to do any action. It doesn't have to take any action. But they don't normally initiate any traffic into the LAN. They are just there to facilitate moving of packets from one segment to the other segment. Okay. Now let us see how they learn. Assume that, let us say node A is sending a frame to node X. Now you may wonder, how does it has learned? Okay, how does the A know the MAC address of X? Okay, that's one question, because I am not saying that it's a broadcast address. It's specific to that particular MAC address. Now imagine ARP has already run, and if ARP has run, bridge would have learned it. Okay, remember, sometimes maybe you can assume that I have configured forcibly the MAC address of X into my host A. Okay, like the packet tracer does it. It puts in the you can even create that thing. Assume that I have created it. I somehow MAC this host knows the MAC address of this, but bridge doesn't know. Okay, right now bridge doesn't know. It puts the MAC address X's MAC address and sends it across. Now, none of the nodes on the LAN 1 would respond to the frame since they are not addressed. Okay, remember that MAC address doesn't match with any of them. So the frames are read by all the machines. Okay, remember, not only the bridges are looking at the LAN traffic, even this bridges host on the same broadcast medium. Okay, assuming that this is a LAN which is a broadcast medium, they will also be receiving it. Okay, so they will keep quiet if they are not addressed. Now bridge on receiving the frame looks at the entry for X. X means here I am talking about the MAC address of the host X. It's not the IP address. Please remember, the forwarding table destination is the MAC address. It doesn't bother about IP address. Okay, it doesn't even know IP is inside the Ethernet frame. It's a data portion of payload portion of the Ethernet frame. The bridges do not even look into the payload of what the Ethernet frame is having. So IP is inside that. So it is only looking at the header of the Ethernet frame, looks at the MAC address of the frame it has received, and then sees whether I have the entry of that particular MAC address in my forwarding table. If it doesn't have it, it doesn't have any information whether it is on the same port or on the different port. Remember, please remember, maybe A is interested to talk to B. Now B is not, it doesn't even know, bridge doesn't even know B is on this side of the fence or this side of the fence. It may send the bridge, Ethernet frame address to B on other side also, because it will initially flood it. So remember, the bridges, if they don't know they're not learned, they do flooding. because they cannot blindly say I will drop it, because that is also very very wrong thing to do, because it has to send it on all of the thing, because it doesn't know where it has to be sent. So it will not just keep quiet, it will send it, because if it is connected it will send it. But only thing is, if A is communicating with B, and they are going to, now B is going to respond back anyway, so whatever the frame with the MAC address of B comes here, these guys will ignore it anyway. Nobody is going to respond back because they are not addressed. So there is no harm in sending it across. Only thing is, it's a unnecessary traffic initially. That's why we want the bridge to be intelligent. We want the traffic to be sent only when it is required, but we are doing it because initially it doesn't know. So now, but it can learn one thing. If A is initiating a traffic, it will put the source MAC address of its own, and it will learn that, okay, I found that the A is on port number 1. So it has made an entry. Now it will do a flooding. Okay. Now it doesn't know where the B is. Okay, or X is. Sorry, X is. Where is X is? It doesn't know. So it doesn't have an entry of X, so it will flood it. Flood means it doesn't have any other number of ports. It has only one more port where it will flood it. It will send it. Okay, it's not called flooding as such. It is just forwarding it. But if it bridges have more number of ports, I am going to tell you that bridges may not be limited to only 2 ports. It can have maybe more number of ports, which is equivalent to a switch. So we call switch also as a bridge when we are talking about the bridge algorithms. Okay, even the STP, spanning tree protocol algorithm, when we say, we call the bridges also having multiple ports. That means what? We are calling switches also as a bridge. Okay, the nomenclature is loosely coupled. Okay, bridge can be, you can call a switch also as a bridge. Okay, so learn now that you have to learn that I may call switch also as a bridge with more number of ports. So now what happens? Flooding is happening. Okay, because it doesn't know, A wants to communicate to X. I don't know where X is because I don't have any entry for X here. That is MAC address of X. Remember. Okay, somehow A has learned the MAC address of X. Okay, that we are not coming to now. And bridge also doesn't know where X is. Okay, that's what your assumptions are. Now X will be sent on port 2. Now what happens? This guy X will anyway see the frame. It will not keep quiet. If it is alive and wants to respond, it will respond back. Now, when X is responding back, it will say source MAC address of X, its own MAC address, and destination MAC address is of A, because it is replying to A. So destination will become A, source is become X. Now that frame will be put on this, because it doesn't know whether it has received from locally or if it has from bridge. Remember, it doesn't know based on the MAC address. It doesn't know whether it is on the same physical segment or it's on the side of the bridge. It just sends it across the LAN 2, who the X is replying. Now our friend bridge now learns that source X is on this side of the fence. So that's how they learn based on the traffic. Okay, so it will create an entry. Now once this entry is done, it has learned about the A and X. Now any traffic between A and X will only like this it will travel. Okay, it's actually, you are not gaining anything because of this learning, because anyway there are only two ports connected. Imagine if this is connected to multiple LAN segment, it will not send it on all of them. Flooding will not happen on all of them. You can expand this bridge into multiple ports. Okay, because I told you that bridge can have more ports than 2. So initially flooding happens on all ports. Once it learns these two, it will happen only between these 2 ports. Okay, so that's how the learning is helping the bridges to be intelligent. Okay, now initially it was doing flooding, and later on it will do forwarding. Okay, so remember, the specific port, if it is sending on, it is called forwarding the decision. Okay, if it has found an entry and then specifically sending it, it's called forwarding. If it doesn't have an entry and just blindly sends it on some other port, it's called flooding. Okay, okay, this is clear now. Now I think this can be extended to other bridge. I am not going to spend time on another communication happening. So one thing I will tell you, what is filtering. Okay, now let us assume that it has learned the location of all the host in the network. Somehow, finally, all of them are talking to each other, and the bridge is now intelligent to um, know which is on which side. Now, if X is communicating, okay, X is communicating it to Y. That means what? Let me write. X is communicating it to Y. X is source MAC address is X, and destination MAC address is Y. Now it comes on this port. Okay, this port it comes. This frame also comes, though they are locally communicating, talking to each other. But it will do a filtering. Why? It is not going to send it on this port now, because it knows that Y is on the 2 and it received it on 2. That means if this guy is really there, he would have also listened to that, he or she would have listened to it. So that frame doesn't have to be sent across. So it is called filtering. It only filters out and sends out only specific frames on the other side. It has, because it has become intelligent now, it knows the location of all the hosts now. Okay, so I hope this is clear now. Okay, this is what is called transparent bridge. Okay, they maintain source addresses of incoming frames by listening to all the connected bridges and host. Please remember, it can be connected to another bridge also, or a host, or a switch, or a hub. So all of them are like different entities, network devices. Whereas bridges and hubs and switches are not going to generate the traffic themselves, unless I will come to that later on. There may be some switches also doing it, L3 switches, but right now we are assuming that they are all L2 switches. So they are not going to initiate any traffic by themselves. They are only sitting there to take from one end and send it to another end. Okay, and while doing it, they learn also, and once they learn, they only send it to specific guys. Okay, or specific ports. So this is working fine. Okay, if the transparent bridging algorithm will work fine for all conditions except for one, which I will come to it slowly. Now it learns from the source addresses, and it will flood until they learn, and they start doing filtering once they learn, and they forward it only if they are required to be forwarded, and they cannot do this, means avoiding loops they cannot do. Now what is the loop? Now that we are not even talked about. So I have 5 more minutes, I think, or 10 minutes, I don't know. Maybe I'll take 10 minutes, we can start 10 minutes late also if you are okay, but I want to logically complete it. Okay, so please hold on to your hunger for till I will not take more than 10 minutes. Okay, one chat is there, hungry. Okay, Karthik is always with hunger. I leave it to you, you can drop off if you want, because recording is there, but I want to complete it logically. Okay, so I will complete one thing and then stop. What is a loop? That's what I want to explain. This is a loop. Why? There is a two path. Okay, two path to LAN 1 to LAN 2. Now what is the problem here? Because as such, remember, bridges are built independently. They are also looking at the traffic independently. Remember, as far as these bridges are concerned, they don't know the existence of the other bridge. Okay, it's like two entries. Okay, you may see that in a city there are rivers, and then there are multiple bridges connecting the one side of the city to other side. Okay, in you can take traffic to any of the bridges. Okay, why do they build multiple bridges across a river which is going inside the city, like Hyderabad or Madurai, where you have a river flowing in through the city and you have multiple bridges? Because redundancy, because of traffic. You can even send a specific traffic, or to build a redundancy into the connectivity. Okay, if one bridge is blocked or something, you can always use the other bridge. So that is the purpose that we have two bridges here. But this result into a problem because of one thing. Initially they are empty, right? So let me explain this and stop. Okay, initially bridge 1 and bridge 2 do not know anything. They are as good as, they don't know what are the hosts are, which side of the host they are connected, which part of the LAN they are connected, and they don't even know the existence of the other bridge in the network. Okay, so they have to do their job. Okay, they are sitting there and they will do the job where they are programmed to do. So imagine that node A sends a frame to node B, so A to B. Now it will be received by this guy as well as this guy. Now what does it do? It doesn't have an entry of A or B here. It doesn't matter whether where B is. Okay, where A is. Actually B only, it has to have an entry. Now it doesn't have entry of A or B. But when the traffic comes from A, it learns that A is on LAN 1. Let me call it as a LAN 1. Okay, or I will call it as a port 1. It is on port 1. Okay, it learns that A is on port 1. Similarly, simultaneously, the same packet is received by this bridge also. So it also learns that A is on port 1. Now, what do? They are programmed to do flooding if they don't know the target MAC address where it is. Now, it doesn't know where the B is. It is on the same side, but it doesn't know. So, it has to send it on the other side. Maybe B is here. A bridge doesn't know. So, it has to do the flooding if it doesn't have an entry of that particular MAC address in the forwarding table of the bridges. Now, the forwarding is not happening, or flooding, sorry, it's not forwarding, it's a flooding is not happening from one bridge, it is happening from both the bridges. That's a problem, because both of them are there and they don't know the existence of the other guy, and they do the job what they are programmed to do. So they send it across the other side of the port 2. Both of them will send it on port 2. This also sends, this also sends. This A packet going to B is actually going here also, but it is also coming here, it's also coming here. Now, imagine for a moment, okay, somebody is receiving it quickly. Bridge 2 receives the frame on LAN 2 with the source address A. Now, what happens is, this is LAN 2, bridge 2, this bridge receives the frame on LAN 2. Imagine this guy is forwarding it first. Bridge 1 is forwarding it, sorry, flooding. Okay, I have to use a proper name. Flooding this packet, A to B packet. Okay, it's not A to B. Okay, don't go to, you all will remember Adayar Anand Bhavan, but I am talking about A T O B. Okay, it's not A to B. So it comes, A to B is, packet is coming here. Now imagine bridge 1 has sent before even bridge 2 wants to do it. Immediately it sees the source MAC address is coming from here, because the packet is same. Source MAC address is A, destination MAC address is B. Now if I see a source MAC address, a frame coming with a source MAC address A, bridge 2 will assume that suddenly A was here and zoom it has come this side. Maybe it's possible. Okay, it's a state, it's not maintaining how much of difference of time it has happened. So it assumes that immediately A is on this side of the fence. So it will update, okay, A to A as 2. Now, what if it has learned A as 2? It has to send it on the other side, because flooding has to happen. So it will send it on the other side. So what will happen is, this frame will go in the loop in anti-clockwise direction. It's called, the loop is having a problem because the same frame is going around the thing. Okay, so that's what I wanted to say before you go to lunch. Okay, so we have to learn spanning tree now. Okay, I have set up the motivation for that. So we will start with spanning tree in the afternoon at 2 p.m. I don't want to hold you beyond this. Unless you have any doubts, we can drop off. Okay, Karthik, I don't know whether he's still around. You can eat now. Any questions before you drop off? 107. So, sir, I will try to attend the next class by chance. Sleep. Huh? This is not good. No, I'm sorry. I don't encourage such messages here. It's your prerogative whether you join or not. Anyway, okay. So thank you all of you. I hope this was useful, and will please come up with some questions before I will give some time for you to ask any questions, not messages like this what is coming from Karthik. I don't want such messages anymore. Okay, you can sleep off, no issues. So please ask me any questions or doubts you have. Okay, bye bye. Sir, 1 minute. Yeah. This is Maran, sir. This is Maran. Okay, 1 second. I know. Hello. Is there, can you hear me? Yeah. Tell me. Sir, can you go to the previous page for just a minute? Yeah. Yes, sir. So we heard you said that as the bridge two receives the packet from bridge one via LAN two, it goes on looping and looping. But at a point of time, we will respond back, right? Yeah, it is not going to be forever. Okay, when the But still I will come to that, in the next slide. When B is responding, that will also be, unless this, entries are same. Okay, remember, unless these entries are same, we will have the confusion. Okay, not only that, not only the entries need to be same, one of the bridges need to stop forwarding. Okay, they cannot be alive both of them and then try to learn. And see, finally they need to have an agreement. Okay, they need to have the knowledge of existence of other bits in the network, and then one of them need to say that, okay, I am not going to do the job of forwarding, I will keep quiet. Okay, you only do the job of forwarding. Okay, they need to have an agreement between them. Otherwise you can you can even, uh, without that knowledge, there will be an issue of this flooding happening. Not flooding, the looping of packet frames happening. Okay, both of them should not do the job. Okay, it's like this. When you there should be only one path for you to go across. Okay, if both of them are doing the job, remember they are independent entities, they don't know the existence of other two in this scenario. So they think that they are the only bridge. Okay, individually they think that they are having the responsibility of forwarding it. Remember, like this. Okay, if you are standing there and then you are told that whatever you see here, you please send it across, and you will keep doing it. Okay, because you will keep seeing it on the other end, and the entries will be different, and there will be an issue. Okay, we have, okay, yeah, that's what I wanted to stress upon, so that spanning tree protocol solves this problem. But I want you to understand the issue of not having a spanning tree protocol. What is spanning tree protocol? Nothing but making one of the bridges inactive. Okay, one of them, any one of them. Inactive means they are not going to go out of, you are not physically going to remove this bridge from the network. It is going to be there, but it will come to life when it is required. Okay, but it will be in dormant state if one is taking over the thing. That's all. Okay. Sir? Okay, sir. Any other question? Yeah, who is that? Sir, Karthik here. Yeah, shall tell me, sir. Sir, in this instance, like this will only result in misconfiguration, right? Like bridge 1 will think key A is on port 1 and bridge 2 will think that A is on port 2. That's all. No, the misconfiguration leads to the repeated framing, packet forwarding. It's not agreeable, addressable, you cannot live with it. Say it's like this. Imagine one guy standing here and then guiding somebody like this. Okay, imagine you stand into cross roads, and then one guy says, "Yeah, you go to RVU on this side." Then you come to this side and you keep asking because you have to ask the bridges, and then they say, "No, no, no, the RVU is on the other end." So it will create a issue if both of them are doing the job of forwarding. Okay, that will be because this will become a loop, right? Yes, that's what we are trying to avoid using spanning tree protocol by disabling one of the bridges not to forward any traffic. Oh, okay, sir. Okay. Any other? Oh, someone is logging within my name. Okay, Karthik, I don't know. You have to protect your own login details. If you share it with, you broadcast your own password to everyone, all the bridges or all the miscreants will misuse it. Don't broadcast your password. Okay. Okay, any other questions? I think you have to go grab your lunch. I will also do, and hopefully please don't sleep off. See you soon. Okay, I'll stop sharing and leave the meeting. Okay, thank you guys. Thank you, sir. Thank you. Bye bye. Thank you, sir. How do I know where to end it? Okay, bye bye.